Good morning, class. So today we're going to learn about using systems of linear equations in context. What does it mean to have a systems of linear equations? So in this opening question, I just want you to think about this. What does all this really mean? So what if I have a graph with two lines? Can that tell me anything? Can I use it? What can I use it for? Well, I mean, it's fun to do, and it's cool seeing math come to life visually, but is there any other context outside of math that I can use this? That's what we're talking about today. So, we have been talking about the solutions of a system, and there's one more method that we're going to talk about next week briefly. But today we're going to talk about how to use it in real life. Okay? So the first thing you got to do is when you look at two equations, ask yourself, what does it mean? When you look at two linear equations, so we have the blue one and the orange one. So if I had a context, let's say I was going to compare how fast one person worked that was by himself versus how fast three people worked that took shifts and turns. And maybe the three people working starts off slower, but eventually they're more productive. Whereas the first person working, maybe he starts off strong because it's just one person, but then he's going to get tired and his productivity goes down. So that's an example of real life. Each line represents something different. So you got to ask yourself some questions. Oops. So the first thing you want to do is label each line. Make sure that each line or each equation matches the context. So the context that I just gave you was working in two different scenarios. One scenario was just one person working, and he gets to start right away. The other one was three people working, but they have to coordinate things. So being able to match each line with the correct context. And remember, the line is only going to represent one of the contexts. The equation is only going to represent one of the contexts. So the question is, look for keywords. When we're talking about something, what does the word total mean? What does the word total mean? So I'm going to show you guys, if you can switch with me here. It's the Khan Academy for today. If we're looking at this, I don't know if you can read, but at the top of this, we have a green line and a blue line, and it says Marcella is using a blend of white corn and yellow corn in her chips when she cooks. She needs to buy 5 kilograms of corn in total. So what does that word total mean? Well, total means it's going to be by itself on one side of the equation. Total means you're adding everything up, adding or subtracting everything up, and then that's going to be the total. So for this one, you see this blue line where it says x plus y equals 50. Well, because it says 50 is the total, I know that 50 is going to be by itself, and it's going to be when you add everything up. That's what total means. Okay, and then again, if you look at the second half, it gives you the cost. White corn costs 30 cents per kilogram, yellow corn costs 15 cents per kilogram, and she wants to spend a total of $12. So again, total means you're going to be adding things up, adding or subtracting, and the total number is going to be by itself on the other side. Another keyword that you could look for is the word per. So what does per mean? Well, again, at this problem, we see that it's $0.3 per kilogram. Per, when you see that word, it's probably going to be the coefficient. When you see the word per, that means it's going to be in front of your x or your y. So sure enough, 30 cents per kilogram for white corn. Well, we have 0.30x. So that was the coefficient of x. That means it's the slope of x. So the word per, think of it, it means that you're going to be multiplying it by your x or your y, by one of your variables. Per means the rate. And then about some other things. If it says increasing or decreasing, what do you think that means? That's going to be your slope. So if you see increasing or decreasing, it's probably going to be in slope-intercept form. And starting point is going to be your y-intercept. So once you've identified and labeled each line or each equation, think about what does it mean to move along each line. So in my scenario, if I'm moving along the yellow line, that means they're getting more things done. If I'm moving along the blue line, that means he's getting things done, but maybe less things done because it's decreasing, it's going down. And then after that, think about which line belongs to the point. When you're given a point in your graph, I'm going to label one right here. Let's say I move this point right here. Is that point, think about what line does it belong to? Well, this one belongs to the blue line, so that means it's going to belong to when just one person's working. If it's in the middle, what would that mean? If the line was in the middle, that means it would belong to both equations, to both scenarios. Both scenarios would be true. Maybe they're working together in this context. And then, of course, if the point that's picked is here on this orange line, that means you're just talking about when the three workers are working. So you think about where is that point located, and that will help you know which context is true. If it's on this line, that means only what's happening here, just one person's working. If it's up here, that means the three people are working. If it's in the middle, it's going to talk about how much they produce, either the one person or the three people group. And if it's not on any lines, that means none of it's true. So that's what it means by think about what line does it belong to. Okay, so we're just going to do a really quick example here. And oh yeah, again, the intersection points means that it's true for both lines. Okay, so here's an example. I have a $5, or let's say 5 dirham coupon for Bed Bath & Beyond. Or I can use a coupon for 20% off. But I can't use them both. So which coupon is going to be better? Well, it depends on how much you're spending. Remember doing the systems of equations earlier when we looked at two coupons? Or we looked at taxis versus Uber costs? That was a while ago, but jog in your memory, see if you can remember. Okay, so now let's look at some equations that go with this scenario. So the one scenario is we have a coupon that's just 5 dirhams off. We have another coupon that is 20% off. So let's look at these two equations. For this system of equations, we have these two. Okay, if I'm looking at y equals 0.8x, I don't even see 0.8 as one of the numbers. So what does that mean? Where is that coming from? Some of you have already figured it out. Pause the video and see if you can match which equation goes with which scenario. Okay, so if you look at this second one, it becomes obvious. The -5, well, that's got to be the $5 off coupon. So the total is going to be the original price minus $5. So if this equation goes with the $5 off scenario, then the other equation must be the 20% off. Let me get a good color here. So this is the $5 off, or the 5 dirham off coupon. Okay, and that means this one has to be the 20% off. So why is there a 0.8 if it's 20% off? Well, if you have 20% off, if you subtract 20%, what's remaining? 80% is remaining. And how do you write 80% as a decimal? You move that decimal point over 2 spots, 1, 2. So 80% equals 0.8. So that's where that equation's coming from. Okay, so just really quickly, I just want to show you the Khan Academy again, and that'll be it for today. Today, you don't have to worry. Don't worry about Flipgrid. Don't worry about doing problems. Just do these 4 problems on Khan Academy, and if you don't do well, just try it one more time. If you get it wrong, make sure you use the hint. Okay, try to get above 50% or better. Really, try to get 100%. That'd be great. But if you don't, and you've tried 2 or 3 times, then it's okay. All right, but I think you guys can do it. So looking at these 2 lines, I think we've determined that this one up here, where it equals 12, represents costs. And this one down here where it says equals 50 represents the amount of corn. So the C I can see belongs to the cost line. It's on here on that green line. So let's read our options. Marcella spends the intended amount of money. Yeah, because it's on that line. And buys the intended amount of corn. No, she did not buy the intended amount of corn. Because this blue line is the intended amount of corn, where she's only buying 50, or exactly 50 kilograms. So let's look at option 2. Marcella spends the intended amount of money. Yes. She buys more than the intended amount of corn. Okay, so it's up here above that line, so that means it must be more. I think. So let's go ahead and check and see if that's right. Yay, I got it right. If you don't get it right, look at the hint and just try it again. Okay? You guys have a great day. Bye.